says here, Krishna is graphing the exponential function y equals 20 times quantity 1/2 to the power of x. Compared to the graph shown down here, which of the following statements are true? Select all that apply. So basically we're comparing the exponential function we have in equation form with this graph down here. Well, immediately you can see the first two answer options both have the word decay rate in it. So we want to know which decay rate is faster, okay? Which one decays faster, goes down faster? Well, this one decays, her equation decays at 1/2. Okay, the rate is 50% or a decay factor of 0.5. Okay, and then let's go ahead and look at the actual graph. It looks like the y-intercept starts at 12 here. You can see it right there. And then by the time it hits x equals 1, remember your x-axis is here, that y value of the function has dropped from 12 and it's come all the way down to 3. Okay, you can see that point is 1, 3. So if you think about it, it went from 12 and it dropped all the way down to 3. That is a factor, or a decay factor, of actually 1/4, right? Because it's going down from 12 to 3, which is like multiplying 12 times 1/4. So which one decays faster? Well, actually, the decay rate of her function is slower than the graph. Okay, because in her function, if it's decaying by 1/2, it would be going from 12 to 6, right? It's going down by half every time. 12 to 6 would be her function of 1/2 decay rate, but ours looks like in the graph is 1/4. Okay, so we have A as the wrong answer here, and we have B as the correct answer. Let's go ahead and jump to C and D now. In C and D, we are comparing the y-intercept of her function versus the graph function. Well, the y-intercept here in the graph we found is 12, or you could write it as a coordinate point 0, 12. And then for her function, if you look up here, the starting value, okay, is 20. Now, how do I know that's the y-intercept? Remember, the y-intercept exists when x equals 0. So in her function, if we plugged in 0 there, we would have y equals 20 times 1/2 to the power of 0, right? If we plugged in 0 as x. Well, anything to the power of 0 is just 1, so it's 20 times 1, which is 20. So her equation y-intercept is 20, and the y-intercept of the graph here is 12. So comparing them, let's read it. C says the y-intercept of her function is greater than the graph function. That is true. Hers is 20, and the graph is 12, and we can cross out D as a wrong answer, so the answers here are B and C.